So we are discussing this problem. Everyone can see the screen now.
Yes, sir.
Okay. So you see, we have discussed this problem in the previous class. What is this problem? This is basically a propped cantilever, right? This is a propped cantilever, and in this propped cantilever, if you see in this propped cantilever, a point load is acting at the middle. Now you see the difference of this problem. It's a simple problem again, but you see in this problem, you see a moment is acting. A moment is acting 20 kilonewton per meter. 20 kilonewton meter moment is acting at a distance 2 meter from the fixed end. Okay, and you see this problem and this problem, the methodology of solving will remain same. If you want to apply the force method of analysis, the methodology of solving the problem will remain same. So what is the methodology? First thing is what you'll have to do, you'll have to find out what is the degree of indeterminacy of this structure. So you tell me, can anyone tell me what is the degree of indeterminacy for a prop cantilever? Bolo? Tell me, how much degree indeterminate this one will be, prop cantilever? This structure is 1 degree indeterminate, 2 degree indeterminate, or it is a determinate structure? Tell, anyone can tell me?
1.
1 degree indeterminate, right? So see, you have given class test just 2 days, 1 day back, right? Yesterday only. So much of confusion. The prop cantilever is a 1 degree indeterminate structure. Where is the indeterminacy? Indeterminacy is here, or it may be somewhere here. So basically indeterminacy is a single degree indeterminate. So 1 degree indeterminate structure. So if the structure is 1 degree indeterminate, then how many redundants will be there? How many redundants will be there? For an indeterminate structure of degree 1, how many redundants will be there? Can anyone listen to me, or are you listening or not? How many redundant forces? Tell me. If a structure is single degree indeterminate, then how many redundants you will have? No answer.
2, sir.
2. Single degree indeterminate structure will have single redundant. See, I am repeatedly telling it that indeterminacy means number of redundants. So number of redundants will be equal to number of indeterminates. So see, in this structure, this is single degree indeterminate. So what is the indeterminate? So the indeterminacy coming because, let's say, maybe because of this reaction force. So if you know this reaction force, then this structure will become determinate, or you should be able to solve this structure using the equation of statics. But if you do not know this reaction here, then you will not be able to solve it using equation of statics. That's why the structure is indeterminate. Okay, so if you just remove this roller from this structure, then what will happen? This prop cantilever then necessarily will become a simple cantilever, and a simple cantilever is basically a determinate structure. So when it is a determinate structure, you should be able to solve it using the equation of statics. But your structure is not determinate because there is another one roller placed over here. So after removal you are getting a determinate, but if the roller is also placed over here, then structure will not be a determinate structure. It will be basically indeterminate structure. So when the structure is indeterminate, and the indeterminacy is coming because of this roller support being placed over here, so the redundant in this case will be what? The vertical reaction force acting at this point B. Exactly the same way we have solved this problem number 1. Okay. So if you go to solve this problem, then and if we take the reaction force at B as the redundant, then what will happen? So if you remove the redundant, what is the definition of a primary structure? So the definition of primary structure is, if you remove the redundant from the structure, then subject to the other external loads on the structure, after removal of the redundant, the structure will remain a stable structure. And after removal of the redundant, the structure will not only be a stable structure, it will be also a determinate structure. So if you see, if I take this structure and if I take this reaction force at B as the redundant force, then what I can do? If I remove this redundant from here, then necessarily I will get a cantilever beam, and that cantilever beam will be subjected to just a moment over here, that is 20 kilonewton meter at a distance 2 meter from this. Okay. So considering that, if we take the primary structure, so I will go to the solution over here. So if you see, so basically I have now a cantilever beam like this, and actually what is there? Actually the beam is something like this, where this 1.28 kilonewton, what you can see, this is not known, this is actually unknown, this is actually your RB, right? So if I take this as the primary structure, then what will be the method of solution of force method of analysis? The method of solution of force method of analysis will be the compatibility method of compatibility, or you will have to apply compatibility condition. So what is the compatibility condition? Basically the compatibility condition is nothing but, in this case, is the deflection at B, because there is a vertical reaction at the prop end, there is a vertical reaction. So at the prop end there will not be any deflection. So if there is no deflection at this prop end, then you can apply the compatibility condition at that point. So the deflection at the point B equal to 0, or the total deflection at the point B equal to 0, that is the compatibility condition, and from that you should be able to get one equation. So as the structure is single degree indeterminate or 1 degree indeterminate, so you have equation of statics, but moreover the equation of statics, you require, for 1 degree indeterminate structure you require another one equation, and that equation you will be getting from this compatibility condition. Okay. So considering that, what you are doing, the second step is, you just find out the redundant, then remove the redundant from the structure. So once you remove the redundant from the structure, the primary structure will become a stable structure and it will become a determinate structure. Once it has become a determinate structure, you should be able to draw its bending moment diagram very easily. Okay. Once you draw the bending moment diagrams of the structure, you can find out the M by EI diagram, and from moment area theorem you can easily calculate the value of deflection, or you can calculate the value of slope. Okay. So if you take the moment area theorem, then for this cantilever beam, which is basically a primary structure in this case, then what will be the moment diagram? Only you see, only a 20 kilonewton meter moment is acting over here. Okay. So if only 20 kilonewton meter moment is acting over here, that is going to give you what? That is going to give you a negative bending moment, something like this, because you see this 20 kilonewton meter moment will be resisted by this support in other direction, which is in the reverse way. So basically that is going to create a hogging moment, and hogging moment means it is negative moment. So you are going to get a negative bending moment diagram, something like a rectangular diagram for this portion. Okay. Now once you have found out the bending moment diagram for this primary structure, what you'll have to do? You'll have to find out the deflection at point B. So how do you find out? So from the bending moment diagram, you first find out the M by EI diagram. So this is your moment, this is your 20 kilonewton meter moment. So 20 kilonewton meter divided by EI, if you do, you will get the M by EI diagram of the bending moment. Okay. Or after getting the M by EI diagram, what you do? You take the moment of that area. Which area? Moment of the moment diagram. Moment of the area of the moment diagram. About what? About the point where you want to find out the deflection. That is actually moment area theorem, right? So you find out M by EI diagram, then calculate the area under the M by EI diagram, and you take the moment of that area about what? About the point where you want to find out the deflection. Now in this case, where you want to find out the deflection? You want to find out the deflection at point B. So this is your moment diagram, and if you divide it by EI, you will get M by EI diagram. So what will be the area of this diagram? So moment diagram का area कितना होगा? How much will be the area? Tell me. 20 by EI into this length, right? 20 by EI into this length. So 20 by EI into 2 is going to be the area of the moment diagram. So this much portion is the area of the M by EI diagram. Now what you'll have to do? You'll have to take moment about point B. So what will be the centroid of this area? The centroid of this area will be at a distance 1 meter. It will be a middle point of this. So it will be at a distance 1 meter from here, right? So somewhere here there will be a centroid, right? So 1 meter from here, and where you will have to take the moment? You will have to take the moment about point B. So how much will be the lever arm of this? 3 meter plus from here to here it is 1 meter. So 3 plus 1, 4 meter. That's why deflection at B, that way using moment area theorem you will be able to get it. 20 by EI into 2, which is the area of the moment diagram, multiplied by the distance of the lever arm. So that is 4 meter. You understand why it is 4 meter? So once you have found out this deflection at B, what is this deflection? This deflection is the deflection of the primary structure because of the external load acting on the structure. Now the next step will be what? But the deflection at this point B is not going to be equal to this much. Why? Because there is a prop 10, this B is a prop 10, so there is no deflection over here. So that is the condition of compatibility you will have to apply over here. So if you want to apply it over here, then what you will have to do? You remove all the external load. You remove all the external load from the structure. And what you do? You apply the redundant at this point. So what you will have to do? You remove this 20 kilonewton meter load from the structure. You have this cantilever and you just apply the redundant force, that is the reaction at B at this point. So if you apply reaction at B at this point, which kind of moment diagram you will be getting? See, it is exactly the same you have learnt over here. So you are going to get a moment diagram in this triangular fashion, right? So it will be, the moment diagram will be in a triangle, and the triangular moment diagram will have value how much? RB into 3 plus 2, 5 meters. So 5 RB will be, so instead of this 20 into RB, so it exactly the same way you will be getting a triangular moment diagram where the value of moment over here will be RB into 5. So from this you should be able to find out the M by EI diagram. So RB into 5 divided by EI is going to give you the value of your what is called first floor. So from this diagram you should be able to find out the value of your what is called value of your m by ER diagram, and from this m by ER diagram again you will have to find out the value of the deflection at point B. Okay, so deflection at point B. So if you want to find out deflection at point B, what you will have to do? You will have to take moment of this triangle about this point B. So what will be the moment? So let's see here, let's come over here. So what will be the moment? You tell me. So it is going to be equal to how much? It is going to be equal to, follow, what will be the area? Area of the triangle. Tell me. Bolo. See, are you with me or you are not listening? You have pen and paper at in your hand? Can you listen? Hello. Hello.
Yes, sir.
So tell, give the answer. Are you not understanding? You are not telling actually. Are you not understanding what I am telling? See, this is the problem. No one speaks. Then how do I understand whether you are understanding or not? How do I know? See, is there any problem? Tell me. Priyanka, are you listening?
Yes, sir.
So, do you have any problem? You are not understanding what I am saying. See, up to this, whatever I have told, have you understood or not? You tell me. Priyanka, I am asking you. Priyanka Bharti, can you listen?
Understood, sir.
Then tell me, why are you switching off your microphone? You tell me, what is the area of this, what is the moment area theorem, and how do you find out deflection because of this reaction at B? Tell me. Tell me. Anuj, can you tell? Anuj?
No, sir.
They see you people are understanding or not? You tell me. You switch on your voice, okay? Because I want to interact. Otherwise, there is no meaning of speaking all these things. Switch on your voice, please. Very less people are here now. Let's interact. Otherwise, you are not able to understand, and I am just speaking and speaking. There is one way talking, and there is no meaning of discussing like this, right? Please switch on your voice and camera, or everyone. Please, let's discuss. Let's have one-to-one interaction. What is the problem you are facing? What is the thing you are not understanding? Please, everyone. करो सब लोग वॉइस ऑन करो तो वॉइस ऑन करो everyone please switch on your voice and camera. Let's see. Everyone, please Let's see what is the problem you are having. Buddhadev? Okay.
Yes, sir.
Very few people, very less people. Okay, so let's have a one-to-one. So we can see our face and then discuss. Okay, Anuj Kumar. Then okay, Jishu Saha. Switch on your voice. Let's see. बोलो अभी क्या प्रॉब्लम है यू टेल मी व्हाट इज द प्रॉब्लम can you see my face or I am not visible
Yes, sir. Visible.
visible okay so you tell me what is the problem you are facing hmm? See unless and until you tell me what is the problem you are facing how can I understand and how can I explain the things that is the problem see what is the part you haven't understood for the problem I am discussing what is the problem what is the part see it's a there is a simple beam right can you see my face and my movement
Yes, sir.
Yes, sir.
so so you see the simple problem is very simple let me explain I think you are not getting the feel of it okay so let's say I have a beam can you see this I have a beam something like this can you see this
Yes, sir.
so let's say this is a beam suppose I am holding it over here so what it is becoming it is becoming a cantilever right it is becoming a cantilever you understand now you understand what is a cantilever
Yes, sir.
suppose I am holding it something like this so what I am doing see if I want to push it something like this then what will happen my hand here I am getting some force so that is basically rotational force I am getting right as well as if I have a load something giving something load something like this then what will happen I am having some pressure over here you just hold a pen on your hand and you see so this is actually a cantilever this is actually a cantilever okay now when you have a cantilever something like this is a determinate structure you should be very clear about it because this kind of structure you should be able to solve it very easily using the equation of statics okay however if you want to solve this structure using if you want to solve another one structure which is not a cantilever but a prop cantilever now what is a prop cantilever you see a prop cantilever means I am putting a support over here so I am putting a support over here at this end okay so then this structure is becoming a propped cantilever now once I put a support over here so what is the support let's say if you can see so let's say this is your support over here so if you put a support at the end of this structure and if this support whatever the support I am showing over here if this support let's say it's a roller support or it's a pin support this will be actually called as a prop this is actually a prop you see this is actually a prop this one so prop means it is the support at this end so this is a prop okay now if you see if you want to analyze this prop cantilever now what is the problem given so there is a moment acting at this point in the structure so if you want to solve this structure when there is a prop over here then what will you have to do you will have to find out the redundant, or you'll have to find out the portion of the force or the different forces which if you remove from the structure will necessarily become a determinate structure. So now see, I have said this one is cantilever. So when this one is a cantilever, then this is a determinate structure. Now if a prop being put over here, then this structure becomes what? This structure becomes indeterminate. Indeterminate to what degree? Indeterminate to degree 1. So when it is degree 1 indeterminate, 1 degree indeterminate, then how many redundants we have? We have 1 redundant. And which one is the redundant? Redundant is nothing but this one, you see. This is the redundant. What is this? This is nothing but the reaction at this end. Which end? That is this prop end. So the prop end reaction is actually the redundant. So if I remove this redundant force from the structure, if I remove this redundant force from the structure, what this structure is becoming now? See, this structure is now necessarily becoming a cantilever structure. And this cantilever structure now can be easily solved using equation of statics. So the method of force or force method of analysis or compatibility method of analysis or flexibility method of analysis, whatever name you call it, okay, necessarily does what? You just prepare first this, you just first try to conceptualize and find out the primary structure. So once you find out the primary structure, in this case this is the cantilever. So let's say there is a moment acting over here. So in this problem there is a moment acting over here. So once a moment is acting over here, you see this structure, if a moment is acting something like this over here, so what will happen? So this portion is fixed, right? So this portion is fixed. So if a moment is acting something like this, this structure will try to deflect in this downward direction, right? There will be a deflection. So from the horizontal position there will be some deflection downward, isn't it? So you will have to find out this horizontal deflection, or sorry, vertical deflection at this point B, which is nothing but the prop end we have spoken about. So if you see, if there is a prop over here, then what will happen? If there is a moment acting over here also, then there will not be any deflection downward. And that is what is actually your condition of compatibility. That you must be very clear. So you see, in the primary structure, because of this moment, you are finding out the downward displacement. And how do you find out this downward displacement? You are just simply applying the moment area theorem. And what is moment area theorem? In the moment area theorem, for the primary structure, you are finding out the moment diagram. And the area of the moment diagram, you take the moment of the, first very clearly understand, moment of the area of the M by EI diagram about the point where you want to find out the deflection. Okay. So where you want to find out deflection? You want to find out deflection over here. So if you want to find out deflection over here, then you just take the moment of the area of that diagram about this point, and that is going to give you the vertical deflection at this point. So this is your deflection. Now, when this moment is not acting on this structure, so next point is what? You forget about this moment acting on this structure. So you remove everything. You remove the moment from here. Then you have what? You have a prop. So this reaction, this prop reaction, you see, you don't know what is the reaction over here. So this is actually your RB. Now, if there is no forces, external forces acting on this structure, then what is acting? Only this unknown force RB is acting on here, right? So only if this one is acting, so because of this force, you see, this cantilever will be deflecting upward, correct? So if you can find out this upward deflection over here, then you equate the downward deflection for the previous case and this upward deflection for this Propten reaction. So once you find out this Propten reaction and this downward deflection, if you equate it, then you are going to get the equation of compatibility, because you know, because of this Propten there is no deflection at this point, correct? So once you equate it, what is there? See, you only have this unknown, right? Only this RB is unknown to you. So one redundant, and you have got one compatibility equation, and from that compatibility equation you can find out this reaction force at RB. And once you find out this reaction force RB, then what will happen? Then the problem is simple. After that, what will happen? This structure, which is basically a prop cantilever, in which this reaction force was unknown, that is the redundant force which is unknown, that you know now. And once you know it, this structure necessarily becomes a determinate structure. This is what is the method. Am I able to understand, make you understand? Does it really make any sense, whatever I have told you?
Yes.
Yes, sir.
Now have you understood?
Yes,
Got
sir.
it? Okay. See, unless and until you do hands-on on the problems, you will not be able to solve, I tell you again and again. So that is what I am saying. See, now I am coming to this mathematics part. So what is there? This is a single moment acting over here. Now you have a moment diagram. You find out what is the deflection at B. So how do you find out deflection at B? You just use moment area theorem. See, if you do not understand moment area theorem, then you will not be able to apply it, because in the next class, after the vacation, when we will be discussing about this Clapeyrion's theorem or theorem of three moments, you will have to understand about three moment equation. If you cannot understand, sorry, not three moment equation, you will have to understand about moment area theorem, because moment area theorem is very, very important theorem through which you should be able to find out the slope as well as deflection at any point in the structure, in a determinate structure basically. Okay, and very easily you can find out using the moment diagram. Ankita madam has discussed it, right? Moment area theorem to you. Moment area theorem, Ankita
Yes, sir.
madam has told you, right?
Yes, sir.
Yes, so you please go through that part, okay, moment area theorem, because if you do not understand that part, if you do not go through that part, then you will not be able to understand this force method of analysis. Okay. Now next is what? Next is, after this removal of this force, if you apply this RB over here, then using this redundant force, you should be able to find out the moment diagram again. So for this there will be a triangular diagram. So from that triangle you again find out what will be the deflection at B. How do you find out? You just take the area of the triangle. Area of the triangle is how much? So when you talk about the area of the triangle means, what is the triangle? Triangle is nothing but the moment diagram because of the redundant force RB. Okay, so RB is unknown. So the moment, what you have to do? You will have to get M by EI diagram. So RB into 5 divided by EI, that is actually your M by EI diagram, correct? So that half into 5. So half into RB into 5 into that base. So what is that base? Base is again 5 multiplied by what? Multiplied by 2/3. See the distance in a triangular diagram, you see. So here if you see, if it is 5 over here, then what you will get? RB into 5. So what will be the area of this triangle? RB into 5, and what is the distance in this case? If you see, this distance is what? 5 meter. So half into, so if you do it, you are going to get half into, or let me just write it in a diagram in this one, then you will be understanding it. So let's say, so you are going to get basically shapes. So let's say let me take a triangle. So let's say you are going to get a triangle something like this, and this triangle, this value, so basically this one from here to here is how much? This is nothing but your, how much you tell me? RB into 5, isn't it? RB into 5. If you are not understanding, please interrupt and tell, okay? Otherwise again you will be at the same page. So RB into 5, this is this one, and what is this length?
5.
What is this length? Tell me.
5, sir.
5. So from here to here it is 5 meter, right? So what will be the area of this triangle? Area of this triangle will be how much? Tell me.
Half into RB into 5
Right?
into 5.
Into
Half into RB into 5.
into 5.
Into 5.
RB into 5
RB
into
into 5
5.
into 5
Don't
into
say
5.
RB into 5. 5 is this ordinate, right? So half into RB into 5 into 5. Now this is the area of this triangle. Now where you will have to find out the displacement? You will have to find out the displacement at this point, right? This is actually your point B. This is actually your point B, right? So if you want to find out displacement at this point B, then from moment area theorem, what will be there? So basically you will have to divide it by 1 EI, because moment area theorem always you will have to apply on the M by EI diagram, not on M diagram. M by EI diagram. So M by EI diagram means EI is what? E is modulus of elasticity and I is your moment of inertia. So the term EI is called what? Flexural rigidity. So if you divide the moment with flexural rigidity, you are going to get basically what? M by EI diagram. So that is the area of the M by EI diagram. Now what will be the moment of this M by EI diagram about this point? So where will be the centroid of this triangle? The centroid of this triangle will be at a distance, you see, it will be at a distance 2/3 of what?
5.
Bolo?
5.
2/3 of 5,
5.
isn't it? 2/3 of 5. Will it be or not? Tell me.
Yes, sir.
Clear? Now it is clear. So now you see this half and this 2 will cancel out. This 2 and 2 will cancel out. Then you are going to get 5 cube, and there will be a divide by 3. Is it now clear? Have you understood it? So what will be the value? See, this 2 and this 2 will cancel out, and then there will be 5 into 5 into 5. So you are going to get RB into 5 into 5 into 5, which is basically 5 cube divided by 3 EI. That is actually your value of displacement at B. Because of what? Because of the redundant force RB. Is it now clear, or still you have doubt? You tell me. Is it clear now, or still you have doubt? Okay. So if you have this, then what you do? You equate both this part. Okay. Now once you equate these two, then you are going to get the value of RB. Once you get the value of RB, life is simple. Exactly the same way you have drawn the bending moment diagram for the previous case, exactly that way you will have to draw the bending moment diagram. Okay. So I should stop here today and take the attendance. So please go through these problems. Okay. I am repeatedly telling you that if you do not understand, you interrupt me and ask me. Okay. So now I hope that you have got some clear idea about what is redundant and what. I have shown you all the details using that pen and pencil. What is a prop and how to remove that prop, and why after removal of the prop the structure is necessarily become a primary structure, and then it is becoming a determinate structure. Then in that primary structure, if you remove that external loading, then only you apply the only you apply the redundant force. Then how the deflection will happen, and how the compatibility condition you will have to apply at a particular point. I hope that you have understood it now. If you still have doubt, please go through whatever I have spoken till now, whatever the materials I have shared with you till now. It's enough material I have shared with you. So you'll have to go through yourself. I cannot, if I keep on telling everything, and if you are not reading it, then there is no meaning. Okay. So please go through these things, because these are very important. See, very simple thing. If you just go through step by step, it's very simple. And what you'll have to do, you'll have to take pencil and paper and work out the problem. Then only you'll be able to understand. Okay. So I stop here today. So thank you very much. Let me take the attendance and then stop. Okay. So let's stop today.
Thank you, sir.
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 Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.